All right, we're going to take a look at some things that give us some real world application, and that's the use of angles of elevation and depression. And I've got a couple of pictures here. One's going to deal with an example, but this first one here at the top, um, really kind of looking at that as just kind of a description of what we're talking about. And so here we have a picture. We got a lifeguard sitting on a stand on the beach, and we have a swimmer out in the ocean. And this segment right here really represents the line of sight from that swimmer to the lifeguard and from the lifeguard down to the swimmer. So as the swimmer is looking up to the lifeguard, his line of sight along with the horizon right here on ground level, let's say, ocean level, ground level, gives us an angle of elevation. And from the lifeguard's point of view, as his line of sight is looking down from this height up here, this gives us an angle of depression. And if we know either the angle of depression or the angle of elevation, we can solve either way depending upon what we're asked. Because if we think about that, these are this right here, there's two parallel lines, and the line of sight is actually a transversal between those two parallel lines, then the angle of depression and the angle of elevation are actually alternate interior angles, and so they would be congruent. And we can use that property of congruency to help us solve things depending upon what we're given and what we may be needing to solve. Now, in both of the examples that we'll be looking at here on page 794 in the textbook, are both going to use actually an angle of elevation. But let's look here at this first one where we got the moving truck. A ramp for unloading a moving truck has an angle of elevation of 32 degrees. If the top of the ramp is 4 feet above the ground, estimate the length of the ramp. So we're told that this angle of elevation here is 32. And here we got ground level. And here we're told that this from the ground level to the top of the ramp here on the truck is 4 feet. And we're asked to find the length of the ramp, x. But if we consider that this is a right angle here, formed by the segments from the ground up to the top of the truck, well then x is actually my hypotenuse. And so I've got an angle measure of 32, and opposite that would be the 4-foot height of the ramp. And I'm trying to find the hypotenuse. Let's see, the sine, SOHCAHTOA, sine is opposite over hypotenuse. So I can use a sine function to find the length of that ramp. So let's say we got the sine of 32 equals 4, the opposite side, over x, which is going to be the length of the ramp, or in fact the hypotenuse. And so let's multiply both sides by x. And so I got x times the sine of 32. This angle of elevation equals 4. And to solve for x, I can divide both sides by 32. And we've got 4 times the sine of 32. And we can use this to find the value of the length of this ramp. Now jot that down. X equals 4 over the sine of 32, because here in a moment we're going to go to the calculator and find that value, estimate that value of that ramp. But before we do, we're going to go over here and take a look at a second example, and then we can just use the calculator for both. So let's move over here and let's look at this second example. And so again, this is all coming from page 794 in our textbook. And here we're told we got a 14-foot long ladder, and it's placed against a house at an angle of elevation of 72 degrees. How high above the ground is the top of the ladder? All right, so let's see. Here's the side of the house. And let's say that this is the ground. I probably didn't have to go quite that long. Let's shorten that up a little bit. Here's the ground. And we got not a straight line, but hey, what can you say? And we got a ladder that's going from the ground to the top of the house. And we're told that this angle of elevation here is 72. All right, so, well, we know that this ladder is 14 feet. That's what it told us right there. Got the angle of elevation here. So how high above the ground is the ladder? So we want to know, what is this measure right here? Let's call that x. And so again, let's think in terms of trigonometric functions, SOHCAHTOA. Let's see, so the sine of 72, opposite over hypotenuse, well, that would be x over 14. So let's set up our equation. So I got the sine of 72 equals x over 14, opposite over hypotenuse. And we can just simply multiply both sides by 14 and solve for x. So we got 14 sine 72 equals x. All right, so again, jot that one down as well. And now we're going to move over to our calculator, do a couple of little quick calculations, and we'll be good to go using angles of elevation. Well, all right, in our moving truck example, we determined that, we'll see, we had an angle of elevation of 32. We knew the opposite side, and so we were trying to solve for the length of the ramp, which could represent our hypotenuse. And so that hypotenuse, or x, would then be equal to 4 divided by the sine of 32. So let's do that. So I got 4 divided by the sine of 32, angle of elevation. Let's close that parenthesis and let's estimate how many feet that ramp is. Well, okay, if I round it to the nearest tenth, it's going to be 7.5. Now our second problem, let's see, we had a 14-foot long ladder, so we knew what the hypotenuse was. We had an angle of elevation of 72, and we were trying to find what would represent how high was the top of the ladder, or the opposite side using right angle trigonometry. And so let's see, if that's the case, I got opposite over hypotenuse. Hypotenuse was 14, our angle of elevation was 72. Well, I could just simply then multiply by that 14 feet times the angle of 72 to give me the height of the house, or where the top of the ladder is. So let's go, we're just going to go 14 times the sine of 72. And let's see, the moment of truth, about 13.3 feet. All right, well, there we go. It's kind of nice to use some mathematics in so what might be a real world application using angles of elevation or depression.